Hi, in this video, I'm going to talk about section 6.2 from the book. The name of the section is Growth and Decay Models. Growth and Decay, okay? So we know that the population growth or decay can happen in many ways, okay? So one of the very famous method or very most frequently when the population growth or decay is the exponential growth or decay. That means that the rate of the change of population, so what that means is the rate of change of population is proportional to the population itself. That means dy over dt equals to it is proportional to y, right? So and that makes sense because you know that if y is bigger, then the rate of change will be bigger. Okay, if y is smaller, then the rate of change is smaller, right? If the last year population or if this year population is big, then you expect the more population change in the future, right? And if the current population is small, then you expect that the rate of change is small, right? Because the producer or the population of the people that produce the new infant will be smaller, and then rate of change will be smaller, right? So that's what it says. The rate of change of the population is proportional to y, okay? And so this can be written as dy over dt is equals to k times y, where k is the constant of proportionality, right? Constant. So, and then if you try to solve this, how do you solve this? You can write 1 over y dy equals to k times dt, right? And if you integrate on both sides, what do you get? If you integrate this, you will get natural log of y is equals to kt plus c, right? When you integrate that. Now, if you get rid of the y, natural log, then y is equals to what? E to the kt times e to the c, right? Or you can write e to the kt plus c, okay? You can write a to the kt plus c, okay? Now, so we're going to find out the value of c. How that look like is, let's say that, so suppose that the population at y at 0 is equals to y0, let's say, meaning that if the initial population is given, then now you use that because this is yt, right? So yt is given like that. Now y at 0 equals to y0, using y at 0 equals to y0 implies what? You get y at 0 is equals to e to the k times 0 plus c, right? So what you get here is basically y at 0 is we denoted by y0, y sub 0, right, is equals to e to the c. Okay, so e to the c is basically y at 0. Hence, what do you get? Hence, y of t, this equation, right, is equals to e to the kt times e to the c, right? But what is e to the c? It is y0. So therefore, y at t is equals to y0 e to the kt. You see that? So this is the solution of that model, that equation, okay? That is the solution of that equation. So where y0 is the initial population, k is the constant of proportionality, we call the growth rate or decay rate. So k is growth or decay rate. What does that mean? That means if k is negative, then decay, then the population decay, right? Then this implies population decay. If that k is negative, then the population will decay for when time goes up, right? Where the time increases, in the future the population will decay. If k is positive, this implies population grows. So that's what we say, right? So basically this is called the exponential model. Okay, this is called the exponential model. This model is called exponential model, and the solution of this type of model, of this type of differential equation is yt equals to y sub 0 times e to the kt, where y sub 0 is the initial population, right? And k is the growth rate or decay rate. It depends on the value of k. If k is positive, the population will grow. If k is negative, the population will decay. Okay, so that's what we get here. All right, now let us see some example, and then we will go from there. Okay, so let's see example. Suppose that the rate of change of n is proportional to n. If n at 0 is equals to 250 and n at 1 equals to 400, find n at 4. Okay, that's what the question is asking. What it is asking is the rate of change of n is proportional to n. That means it is like dy over dt is proportional to dn over dt is proportional to n. N is the number of people, let's say. Okay, so solution, what it is given is dn, the rate of change is dn over dt is proportional to n. This is same as dn over dt equals to, you can write kn, right? Or you can write rn. Let's write down rn. R is the rate. Rn. Okay, the r is the constant of proportionality. But when you solve this, what is the formula for the solution? Nt is equals to n at 0, right, times e to the rt. That's what you got, right? Because we see that if the equation is dy over dt equals to ky, then the solution is yt equals to y0 is the initial population times e to the kt. So we have, instead of k, we use r here. So nt is equals to n0 times e to the rt, right? Now what it is given here is n0 is 250. That's given. So n0 is 250 means 250 is equals to n0. Oh, so n0 is 250, so you don't even need to do that. So that will be what? Nt is what? Therefore nt is equals to 250 times e to the rt. That's what we have, right? Now what we want to do is we want to use, we don't know what is r, we don't know what is the growth rate. Okay, so how do I find out the growth rate then? To find out the growth rate, you need to use that information. Using n1 is equals to what? 250 times e to the r times 1, because I'm replacing t by 1, right? But what is the value of n1 is 400. 400 equals to 250 times e to the r. Now divide by 250. What do you get? You get divide by 250, divide by 250, divide by 250. This will cancel out, right? So 0 and 0. So what do you get? 8 over 5. That means e to the r equals to 8 over 5, right? Take the natural log. What do you get? R equals to natural log of 8 over 5, because when you take the natural log to the e to the r, that r goes to before the natural log, and what is left is e, natural log of e, which is 1, right? That's why r equals to natural log of 8 over 5. That's what we got. So how much is that value? So natural log of 8 over 5 is equals to so let me find out that. So natural log of 8 divided by 5 is equals to, you get 0.47. So the value of r is 0.47, right? But what is the question? You need to find out n4. So what is n4 then? Let us plug in that. N4 will be what? I'm going to put it here, right? Equals to 250 times e to the r is 0.47, right? And then t is 4 times t is 4. That's what you do, right? So what do you get? You get 250 times e to the so e to the 0.47 times 4. Okay, if I do that, I get 1638.38. So I got 1638.38. that is 1639. The total population after 4 years will be 1639, because you see that at the beginning there were 250 people at the beginning. After 1 year there were 400 people. So using those two information, we got the growth rate is, because it is positive, so that's I am saying growth rate. So we got R is equals to what? 0.47. Now to find out n at 4, I'm just plugging in R equals to that value, and then T is equals to 4, and plugging in here I get 250 times e to the 0.47, and then times T is 4. If I do that, then I get 1630. So after 4 years the population will become 1639 almost, right? That's what we get. So another example is, let us see example. Says radioactive radium has a half-life of 1599 years. So let's say radioactive radium has a half-life of 1599 years. What do you mean by half-life? So if there is certain amount of radioactive material, radium, if there is a certain amount of radium right now, and after about 1600 years, that will decay to half of it, half of the current amount. Okay, so the question is, what percent of given amount remains after 100 years? So what percent of current amount is left after 100 years? After 1600 years, that will be half of the current amount, that is 50% left. But what percent will be left after 100 years? That's what the question is, right? Solution. Suppose that A is the amount. Okay, you can write A is the amount, or R is the amount, or whatever. Okay, so we are using basically the same model, that is dA over dt equals to RA. R is the growth rate or decay rate, right? What is the solution of that? A of t is equals to A0 times e to the RT, right? What is the question giving? The half-life is 1599 years, right? That means at t equals to 1599, AT will be half of the A0, right? That's what it is given, right? That's the half-life is. After 1599 years, the amount will be half of the original amount, right? So when you do that, then you just plug in here. So you get A0 over 2 equals to A0 e to the R times 1599. That's what I'm doing. Okay. Now divide by A0. What do you get? You get 1/2 is equals to e to the 1599 R. Let us take natural log. What do you get? You get 1599 R equals to natural log of 1/2. So R will be what? Natural log of 1/2 divided by 1599. Okay, so that will give you, if I use calculator for that, then you get natural log of 1/2 divided by 1599. If you do that, you will get negative 4.3348 times 10 to the negative 4, which is same as this 0.123 123 and then 4. So and then 3 0.04, because what that 10 to the negative 4 in your calculator, you will get e to the negative 4, which is same as 10 to the negative 4. 10 to the negative 4 means you are dividing by 10 to the 4. Okay, and then you see that you will have 4 digits after the, so before this decimal you will need 4 digits. That's why I added 3 zeros there, and then that decimal will move there. So 0.000433. That's what you get. Okay, so that is the value of R. Now what it is asking is, what is the value of AT after 100 years? So what we do there then is, so let us find out that, therefore after after 100 years, AT or A100, right, will become what? A0 is A0 times e to the R is 0.000433 times in the exponent, okay, times T is 100, okay, so T is 100. So what do you get? That is A0 times e to the 0.0433, because you see that 0.00433 times 100 will become 0.0433. So after 100 years, that's what you get. Okay, so what percentage is left then? So the question is asking what percent of the current, because the current initial value is A0 is the current value. Okay, so how much will be the after oh, by the way, this will be negative, okay, negative of that, I cannot forget that, negative of 0.00043. so let me write down that negative sign here, okay. Now, so what will be the amount after after 100 years? Let me find out this value, how much you get here. So you get, what is e to the negative 0.0433? so it will be e to the negative 0.0433 is same as 0.9576, okay. So A0 times 0.9546, that's what you get. That's what e to the negative of that, okay. So how much is this value from the given value? Then what percentage is that? Okay, so the question is what percent of current amount is left after that. So what percent is left is, you just find out. So the percentage left is what? So you can write this divide by A0. So A0 times 0.9546 divided by A0 times 100%, right? That's how we find out the percentage, right? So A0 and A0 cancel out. So 95.46% is left after the 100 years, okay? Because the half-life is about 1600 years. So after 100 years, about 95.46% of the radium will be left in that environment. So the decay of the radium, the radioactive material, radium, is very, 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 very slow. Okay, guys. So so you may have seen this formula. The next formula is the compound interest formula. Okay, so compound interest, you have seen that in the college algebra, but this is, again, we can use the similar formula as we did in the solution of the exponential growth or decay. Okay, so compound interest, compounded continuously. So compound interest compounded continuously is, so if you invested some amount in a bank that give you the interest compounded continuously, then what is the formula? Do you remember that? That formula is A equals to P e to the RT. So where R is the rate, okay, the interest rate. R is the interest rate. You need to write that interest rate in terms of the decimal value, and then T is the time, P is the original amount, okay. So let us see one example. So example is, if let's say $4,000 is invested with rate 6% per year, find the doubling time. What is the doubling time means? The time it needs to become 8,000, right? Also find the amount after 10 years. Also find the amount after 10 years. Okay, So how do I find out that solution? What is given? P is 4000, right? And then R is 6%, that is 0.06. So you want to find out the doubling time. So doubling time means when will be, so when will that A becomes 2 times the original amount? That is, we want to find out the T time. Okay, so we do 8000, that is double of that, equals to 4000 times e to the 0.06 times T. Now you want to solve for T. Now divide both sides by 8000. What do you get? Sorry, 4000. So 2, because that will cancel out, right? So 2 equals what? E to the 0.06 T. Okay, now you need to take log. You get natural log of 2 equals to 0.06 T, because when you take the log on the right side, that exponent on the e to the exponent, that exponent comes before the log, and the natural log of e will left, that is 1. Okay, now divide by 0.06. Okay, so if you divide natural log of 2 by 0.06, natural log of 2 divided by 0.06, you get 11.55. so the doubling time is 11.55 years. That is one question. Okay, so the another question is also find the amount after 10 years, right? So what will be A at 10? So that will be, it is P, okay, times e to the RT. R times T is 10, right? So what is P? P is 4000 times e to the R is 0.06 times 10, right? So how much is that? That will be 4000 times e to the 0.6. Okay, so if you use calculator, what do you get? You get 4000 times and then e to the 0.6. That's what you get. You get 7288. So after 10 years it will be 7288.48. That's the amount after 10 years. Okay, if the interest rate is 6% and continuous compounding, it's 4000 invested with rate 6% per year. Find the doubling time, also find the amount after 10 years if the interest is compounded continuously. Okay, so this is assumed here. Usually the question tell you if the interest is compounded continuously or not. Okay, so here we assume that it is continuous compounding. Okay, continuous compounding. This is the default assumption on this example. Okay, so we have done this type of problem in college algebra, so you may have seen this in other places too, but this is just easy problem. So you have the main formula is A equals to P e to the RT. A is the amount after time t. You can write AT equals to, and P is the principal amount, that's the beginning amount. It's similar to that, right? You see that? That's similar to that one. And then P is the initial investment or the initial amount, and then e to the RT. R is the interest rate per year. R is the interest rate per year. That R should be used as a decimal value. If the percentage is given, you need to change that to decimal value. And T is the time, also in years. Okay, that's what you should be using. Okay guys, so that's the end of section 6.2. all right.